Hello. In this video, we're going to solve radical equations that lead to linear and quadratic equations. So, just like last time, we want to make sure that we know what values are allowed to be solutions, and then we'll need a little bit more tricks in order to solve radical equations. So, let's just go ahead and get started by trying to solve this. What I really would like to do is to square both sides in order to get rid of this radical. In order to do that, I'm going to move everything else to the other side. Because now when I square both sides, the radical is going to go away, and I'll get this 8 squared, which will be 64. So now it's easy to solve, and I get x equals 71. So in the last videos, we were saying, okay, let's go ahead and make sure that this number is in our domain. And so is that x greater than or equal to 7? Absolutely. So this is a solution. Normally, it may be a little tough to solve for when the radical is greater than or equal to 0. And so in those cases, we normally say to plug it in and check that this is a proper solution. So we could have also done this and said, okay, is this equal to 6? Well, 71 minus 7 is the square root of 64. Is 8 minus 2, 6? Absolutely. All right, so let's try that again. The square root is by itself, so we'll start by squaring both sides. Move that 10 over. And we'll divide by 2. So again, because it's normally easier to just plug this in rather than solving underneath the square root, we'll just plug this in. Is 2 equal to the square root of 2 times negative 3 plus 10? Well, that's the square root of negative 6 plus 10. And yeah, that works. So you don't have to worry about having these negative solutions. Those can happen. Because if we had solved 2w plus 10 greater than or equal to 0, we would have seen that as long as our value was greater than or equal to negative 5, it would be in the domain. It would be something that we could have as a solution. All right. So now, again, I have 2 square roots this time. If I wanted to just solve this one, I would need to move the other square root to the other side. And we actually get something nice in this case. Now I can square both sides, and both of them go away. And I can solve. 2z plus 13 equals 7. 2z equals negative 6. Z equals negative 3. So we saw from last time, if I have 2 square roots, I'd have to solve them separately and then check where they're both solutions. And in this case, this is how we see it's much easier to just check that whatever we get can be a solution. So we'll just plug it in and make sure it works as intended. So that's negative 6 plus 7, negative 12 plus 13. 0 equal to the square root of 1 minus the square root of 1? Absolutely. So negative 3 is the solution. So in all three of these cases, the square root led to a linear equation, and so there was only one solution to check. In this case, the square root's by itself, so we'll square both sides. And then on this side, we get something a little bit different. We get this u squared minus 2u plus 1. So when we move everything over, we get a quadratic. So we'll have two possible solutions. So go ahead and trying to find and factor this. We wanted two numbers that multiply to be 18, add to be negative 9. You can see I went through them in my head and I found 6 and 3. So I can solve these separately. Get u equals 6, u equals 3. And then again, I need to plug these in because I don't know what my domain is at this point. I haven't solved for it. So if I plug in 6, all right, and that would be the square root of 25. And yeah, looks like 6 works. Now we plug in 3. And we see, yeah, in this case, 3 also works. And we would have known that if we had solved. And so this is saying u is greater than or equal to 2 point something. And that's why both 3 and 6 work. They're both in the domain for this equation. And that's all in this section. So again, for radical equations, get the square root by itself and then square both sides. And to make sure that your value is in the domain, either plug it in or solve where the radical is greater than or equal to 0.